So, during this lecture session, that is the fourth one. Now, I would explain another the numerical problem. This is the typical the numerical example related to MRP, and then we will discuss the evolution of MRP systems, particularly the MRP2. The MRP system in general is made available in different forms, and as the situation in the production system the changed over the time, so the MRP system also got changed to different forms, and in today's context we talk about so the enterprise resource planning or the ERP, and we also refer to so the distribution requirements, the planning, and but the MRP system is the basis, the original MRP systems. Later on it evolves into manufacturing resource planning. So, what is manufacturing resource planning? We will explain, and one point you must note that many companies these days they have been using the ERP, enterprise resource planning. Now, the entire so the ERP or the enterprise resource planning is based on the logic of MRP2. Is it okay? So, MRP aspects you must know, MRP2 also you must know in details, so that you know that why do you use the ERP systems these days. Now, let us take up one particular example, and this example, the example already we have discussed three numerical examples. So, this is the fourth one. Consider the product structure of end item PR1 given in figure. So, I will show you the figure. So, the end item PR1, that means this is the code. So, all the end items, or for that matter any item or any say the sub assemblies what you find, so they are to be properly coded, and this is the responsibility of the design department, and many a time the process planning department also gets involved. So, it may be the responsibility of the process planners also. So, so any end item or end product with this the code, the product structure is given, bill of material in a product structure form, the hierarchy that is given. The end item demand from the master production schedule. You already know what is the master production schedule for the period of weeks 3, 4, 5, 6, 7, 8, 9 and 10. That means from the third week to the 10th week. So, the demand levels are specified, the gross requirements. There is 40 units, 30 units, 20, 10, 50, 30, 70 and 20 units respectively. At least with this data set, you may find some kind of pattern. So, this is very is a particular case. So, as I have already pointed out, that the first thing you need to do, that means you look at the data pattern, whether it is erratic or not. In majority of the cases these days, particularly for the end item demand, you may come across the erratic demand pattern. So, the manufacturing and assembly lead times, there are two aspects. One is the manufacturing part, and manufacturing is followed by the assembly. That means first we talk about part manufacturing, and part manufacturing, then the followed by the assembly. Now, the lead times for PR1, SA12 and C122, That SA stands for maybe the sub-assemblies coded as 12, and the C may stands for the component coded as 122, and the ordering lead time for M4, that means maybe the material, M stands for the material. So, you have the sub-assemblies, you have the component and you have the materials. So, the ordering lead time for M4 are given below. So, this information is given. Carry out the material requirements planning procedure for raw material M4 required to manufacture component C122. If 1 unit of M4 is required to produce 1 unit of C122. So, apparently it is a simple problem, but if you solve these problems, so you will come to know the intricacies involved in MRP computations. Okay. Now, the lead time for assembling, that is the PR1, is 1 week. Lead time for assembling sub-assembly is 12, is also 1 week. So, lead time information is a must, and please make a note that we are assuming that the lead time is known. That means there could be fluctuations in lead time, but here for the MRP systems we are assuming that the lead time remains constant. That means this is problem under certainty as far as the lead time is concerned. Now, this question these assumption may be questioned. So, later on you may relax these assumptions. So, under certain the conditions, you will find in the latest versions of MRP certain the statistical analysis also is allowed. Is it okay? Or some kind of say the inferential statistics also you can employ, but that is that extension in order to the bring in the concept of mathematical modeling or the statistical modeling, okay, so that the working of the MRP system becomes improved. So, right now we are we are assuming that the lead time remains constant, known with certainty. Lead time for manufacturing C122 is 2 weeks. 100 units on an inventory are given and 40 units are scheduled to arrive in period 2. That means at time t equals to 0, this is the scenario. Okay. So, when the entire the plan will be made, is it okay? So, procurement lead time for raw material M4 is 1 week and 40 units on hand inventory are available for this material. So, this is the present status at time t equals to t or time t equals to 0. So, this is essentially your the bill of materials. So, this bill of material or the product structure in hierarchy is given by the design department. So, as already I have mentioned that this is the end item, the code is PR1, this is level 0. It consists of say the 2 sub assemblies, one is SA11 and the second one is SA12. So, the PR stands for product, SA stands for sub assemblies and the C stands for the component. Okay. So, in order to produce 1 unit of the product or end item, you need 2 units of sub assemblies 11 and 1 unit of sub assembly 12. Okay. So, this is level 1. So, for these 2 sub assemblies, the parent item is the end product or the PR1. Now, in order to produce 1 unit of sub assemblies 11, what you require, that means you require component 111 and component 112. So, for component say C11 and C112, the parent item is subassembly 11. We have already used these terms, and to produce 1 unit of subassemblies 11 SA 11, you need 3 units of C111 component C111 and 2 units of component C112. And then this is the level 2, and at level 3, to produce this component C111, you need the raw material M1. To produce C112, okay, you require material of type M2. That means this is a raw material, so it's so the chemical composition will be specified and including the physical properties. So, based on the physical properties required as well as the chemical compositions required, and the chemical compositions actually may determine the physical properties. So, you select when that the physical properties as required for this component, you select the appropriate raw materials. Similarly, for the subassemblies 12, you need component 121 and component 122. For component 121, you require material of type M3, and for component C122, you require the material of type M4. So, C121 and C122, both of these items or these components are having the parent item called SA12 subassemblies, and to produce 1 unit of subassemblies 12, you require 1 unit of C121 and 2 units of C122. So, this is the explanation of the product structure hierarchy or product structure code or bill of materials. So, you come to know from this explanation that at what point in time which say the component or which the materials you require when the lead time is known, and what is the sequence of the activities or the sequence of operations you say need to say the carry out for getting the final product PR1. Now, you have all this table. Already we have referred to say example 3, and you have come across such a table. So, these are the 4 parameters. We have the gross requirements, scheduled receipts, projected on hand, net requirements, okay. Then the planned order receipts and the planned order releases. So, how many the time periods you have considered? You have considered the 10 time periods. Okay. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the first the row refers to the gross requirements. So, the gross requirements from the 3rd time period, these gross requirements are given already, and the net requirements is absolutely same as the gross requirements. Planned order receipts is this one, and the planned order releases, that is this one. That means that is just for that means for this item, that means this is for say PR1, that means the final or the end product, and for end product essentially it is an assembly work, and for carrying out the assembly work you need 1 week's time. So, that is why the lead time is 1 week. So, for each one, that means the planned order receipts, this is this, and as this is there is say so the lag time or lead time of 1 week. So, the planned order releases will start 1 week before. So, this is the interpretation of this table for the final product PR1. So, now what you try to do, that means the gross requirements are known, net requirements we have already calculated, and the planned order release is already known 1 week say before, as the lead time is say just 1 week. Now, suppose the gross requirements is 40. So, lead time for assembling SA12. So, this is 1 week. So, you require these items, the gross requirements for sub assemblies 12, and to produce say 1 unit of say the product, you require say 1 unit of sub assembly 12. So, this information you get from the say the bill of material, say the figure. Now, this is the gross material. So, that is why MRP table, for when you create this MRP table for sub assembly 12. So, the gross requirements immediately you can calculate same 1 unit. Net requirements will be the same. So, the planned order receipts is this much, there is no change, but the planned order releases will be on the first time period. That means, the 40 units required on the second, okay, say the time period. So, you need to release the orders, okay, 1 week before. That means, on the first week you must release the orders of 40 units, as the lead time is 1 week. So, this way you calculate. Okay. Next, you have this period, that means these are the periods in fact you have, and for the sub assemblies 12. So, sub assemblies 12 is this is the gross requirements 40, 30 like this, net requirements remain same. Now, here the lead time is 40. So, this is your say the planned order releases already completed. Now, lead time for manufacturing component C122. So, that is 2 weeks. 100 units on hand inventory are given and 40 units are scheduled to arrive in period 2. That means, here what you require, that means for to produce say 1 unit of say SA12, that is the sub assemblies, you require 2 units of C122. So, what is the gross requirements? Then the gross requirements is 40 into 2, that is 80, 30 into 2, 60, and so the same way you calculate the gross requirements for the component C122. That means, at what time you require you require to supply a specific item that is specified. So, the gross requirements in time say week 1 you have 80, 60, 40 and so on for the remaining time periods. The scheduled receipts is 40 units. So, that is mentioned that 40 units are scheduled to arrive and period 2. So, this is your updated information. So, projected on hand, this is also mentioned, that means 100 units on an inventory are given. That means, the projected say demand, that is 100 units projected on hand. So, 100 units are already there. Now, so 80 units you require. So, you have remaining 20. Now, the scheduled receipt is 40. So, 20, that means 40 units and 40 units already you have. That means, there is a shortage of 40, but you have a scheduled receipts of 40 and the second week. So, you have the projected on hand is 0. Okay. Then the net requirements obviously in week 3 will be 40, in week 4 it will be 20 for component C122, and for all other weeks these net requirements you can calculate for the component C122. So, the planned order receipts will be this one, and here the lead time is 2 weeks. That is why these 40 units you require in week 3. So, the 2 weeks before you place the order. So, the order must be released in week 1, and if you release if you release the order in week 1, it is expected that after 2 weeks, that means in week 3, you will get the receipts of 40 units. Is it okay? So, here what you have, that means 40 units you receive, 60 units is 0. So, you require say the 20 units over here. Is it okay? So, the 40 units over here, that means 40 is 60 and 60 into 40 we have. So, you have already 100 units. Is it okay? So, the 100, 60, 140 and 40. Is it okay? So, planned order releases will be 20, this will be 20, this will be 100, this is 60, this is 140, this is 40. That is it. Okay. So, this way you calculate the values of all these parameters for the component C122. So, similarly, what you do, that means now once this is known, now this CA122, this component is related to say the M4. You require the materials of type M4, raw materials of type M4. So, the lead time for procurement is say 1 week, and 40 units on hand inventory are available for this raw materials. So, what you have, that means you require 40 units in the first week, second week 20 units, third week 100 units, fourth week 60 units, fifth week 140 units and the sixth week 40 units. So, the projected on hand that is given, that is 40 units. So, okay, for this particular problem. So, you have now projected when the 40 units are consumed. So, obviously, you do not have any units as projected on hand. So, the net requirements will be 20, 100, 60, 140, 40. Planned order receipts will be 20, 100, 60, 140, 40. Okay. And so, as the lead time is 1 week. So, 1 week before you place an order of 20 units, and then the next week you place an order of 100 units, next to next week 60 units and so on. Okay. So, this way you make a plan for the order releases. Now, so this is a typical problem. So, you please go through this particular problem, and there could be many other kinds of problems you may come across MRP, but this the 4 kinds of problems, the numerical problems which we have discussed, these are very typical, and my suggestion is that you go through these problems, and I am sure that once the concept is made very clear and you understand the computation procedure, the remaining matters are very routine, and it's very and the simple so the arithmetic calculations you need to do. So, there are several assumptions and there are certain limitations of MRP systems. So, before you apply an MRP systems in a given situation, so first you check to what extent it is feasible. If it is feasible, then only you will go for it. If it is not feasible for the given item, is it okay? So, you assess the present situations. So, and if you find it is not feasible, that means there are many the data are not the reliable, and there is a risk involved. So, you do not go for MRP systems. So, there are certain conditions to be met. Evolution of MRP systems, MRP2. Now, before I discuss the DRP, I will also refer to MRP2 systems, because originally during mid 70s or so early 70s, the MRP system was introduced or adopted by several organizations across the globe, and progressive organizations. Now, later on, as the situation changes, or the assumptions in a real systems, which the assumptions which you made originally for creating the MRP systems, suppose these assumptions they never remain valid, say the later years. So you need to change the MRP systems. So so it has evolved through certain stages. So from the MRP systems, initially it was an open loop system, then it moved to closed loop MRP, and from the closed loop MRP, now we moved toward say the manufacturing resource planning, which is normally or usually known as MRP2. So the MRP2, in MRP2, the MRP is known as manufacturing resource planning. So MRP system was originally developed for online real-time method of ordering inventory, keeping in mind the constraints imposed by production system and purchasing system. Major emphasis later shifted to scheduling. The scheduling is the most say the difficult part, and so establishing the proper the scheduling method is a real challenge. So a major emphasis later shifted to scheduling, establishing and maintaining valid due dates on orders. Okay. Subsequently, MRP evolved to manufacturing resource planning, and this is referred to as MRP2, that means the second version. Through the closed loop MRP, I have already pointed out, that considers effective planning and control of all the resources of a manufacturing organization, not necessarily only the inventory items or inventory systems. A typical closed loop MRP system is presented in the following figure. Okay. So MRP, so let me the first explain the closed loop system. Initially it is an open loop system, so as you referred to the pictorial representations of the MRP systems, the original MRP systems. So you conclude that this is an open system. Now so any open systems you create, there is a risk involved. That means you may not have the feed forward the loop, or you may not have the feedback loop. So it becomes difficult to correct yourselves, and there may be many other kinds of risks. So it is always better that you opt for a closed loop systems, because all these the components in the systems, MRP systems, they are interrelated. So let me just the next 2 to 3 minutes of time, let me just highlight the important aspects of the closed loop MRP systems. So like you have the master production schedule. So the other inputs are product forecasts, production plan you must know, and the customer orders. This point already we have elaborated. Now this master production schedule MPS, when you prepare, it depends on the production capacity planning. So the capacity planning for the personnel and capacity planning for the equipment and the facilities, these are the two important issues. And then what you do, you go for material requirements planning, that is MRP. So you have the inventory status records and you have the product structure records. Then you have two types of the actions, outputs. One is the planned order releases, and you have the released work orders. Is it okay? So this is related to the purchase orders, this is related to the work orders. Now with this, what you try to do, that means you have the capacity requirements planning. To what extent this is the production capacity planning, this is the capacity requirements planning, or the CRP, what capacity is needed. This issue you need to consider. This is a very important issue, in fact, the capacity planning. So now the question is raised, is the capacity available? If it is yes, then obviously you go for the purchase orders and you go for the work orders. If it is no, then obviously you need to change the master production schedule, because it should match with your capacity. Is it okay? So the capacity planning is a very important issue to be considered before you become ready for the MRP systems. So is a closely linked. So in a closed loop MRP, what you try to do, that means the MRP system is linked with the capacity planning systems or the capacity requirements planning systems. So now if the capacity is available, then you go for the purchase orders and you go for the work orders proportionately. And the loading and sequencing, this is an important issue, work orders, that means in-house production. So these two issues are related to basically the sequencing, loading and sequence is the part of the scheduling, with the job shop scheduling, or so the whatever it's the flow shop scheduling also you need to consider. And then but essentially you go for the job shop scheduling, because I have already mentioned that the MRP is applicable principally for say the repetitive manufacturing. So now you go to selection of the suppliers, and this is a part of manufacturing, and then the products are manufactured and sent to the customer. So this is the closed loop MRP systems. So whenever you focus on the MRP systems, so but you must have in your mind that the MRP system is a part of the closed loop MRP systems, which is, that means it's very much linked with the capacity planning system. So with this understanding of the closed loop MRP systems, I conclude this session, and in the next session I will be discussing the MRP2 systems, manufacturing resource planning systems, and the DRP systems, distribution requirement planning systems. Thank you.